Okay, now let's go ahead and let's do an example of what we just talked about with these sets and see if we can make it make sense. So here we have a set of numbers that has listed out each of the elements. So if you'll remember, this is the roster method of describing a set. So we want to list the numbers in each set described. So first of all, we're going to talk about the natural numbers. What they're asking us is, which of these numbers is a natural number? Well, we need to remember what natural number is. It's that very first set that you ever learn, like when you're learning to count. So we need to go through here and we need to list each of the natural numbers, and that would be 3 is a natural number. Are any of the others natural numbers? No, they're not. Because remember, the natural numbers are 1, 2, 3, 4, 5, so on and so forth. Now they want us to list out the whole numbers. Well, here again, let's remember what a whole number is. Whole numbers is the set of natural numbers adding 0 to the mix. So we know that 3 is part of the whole numbers because it was a natural number, and every number that's a natural number is also a whole number. But the whole numbers also includes 0, so that would be 3 and 0. Now then, remember we made a bigger set because we found out that there were negative numbers. So when we added those in, they became the integers. So as we look through our set here, we know that 3 and 0 have to be integers because they were also whole numbers. And remember, the whole numbers, it was a little smaller set inside the integers. But let's look at what else we have here. We have a -1, that is an integer. And then, let's see, we've already done 0. That's not an integer. This is not an integer. But -8/2 is an integer. Even though it looks like a fraction, if we were to simplify that, -8/2 is actually just -4. And that is an integer in just a different form. So we have to be careful. Now it's asking us for rational numbers. And remember, rational numbers are anything that can be written as a fraction. So let's see, 3 could be written as a fraction. It could be 3/1. -3/5 could be written as a fraction. It is. -1 can be written as a fraction if we put that over 1. 0 could be written as a fraction because it could be 0/1, right? Now what about the square root of 2? Can that be written as a fraction? If you'll remember from our examples, we said the square root of 2 is an irrational number. So I'm going to go ahead and put it with my irrationals down here. Now 5.94 repeating. Anytime that a decimal repeats or it terminates, stops, then it could be written as a fraction. It's possible to do that. So this is actually a rational number, 5.94 repeating. Okay, our next one here is 4.2122122212221. On and on and on forever. This is a non-terminating, non-repeating decimal. It looks like it repeats, but not in the exact same pattern. So therefore, it is an irrational number. So I'm going to go ahead and put that one here, and I think I'll just do ... there. Now, -8/2, that is a fraction, so it is a rational number. The square root of -1, well, you can't really take the square root of a negative number, so we're just going to ignore that one for a minute. And then here we have pi/2. Pi is an irrational number, so even half of pi would still be an irrational number. The last thing that they're asking us about is they want to know which of these are real numbers. Well, remember, real numbers are the rationals plus the irrationals. So in this case, we would write out every one of our numbers except the square root of -1. And we're going to do that in a last chapter.